Okay. Now this time we have a path integral, but it's a line integral, but I'm only giving you the endpoints, right? And there's no description about what kind of curve this is, right? So it's some kind of curve. So this is like integration over some curve C, where this curve C begins at 0, 0 and ends at 2, 1. But we have no idea what kind of path it is. It could be like something that is just going crazy and then ending there, or it could be a straight line. We don't know. Okay? However, if you ever see a question like this, you should think of this as like a hint that the given vector field is a conservative vector field. Because, I mean, if it's not conservative, then we know that this integral definitely depends on the path itself, not just the endpoints, right? If it's a straight line or if it's going like that, the integral will be different if the given vector field is not conservative. So if you just have a line integral where you're just given the initial and final points, or sometimes you may be getting a question that says, let C be a path from 0, 0 to 2, 1. Calculate integration of f dot dr over C. That could be another way this question could be asked. Okay? Either way, when you're given a path from 2 points and without any description of what's happening in between, that must mean that your vector field is conservative, or else there's no way you can compute it, because the integral will depend on the path. Only when it's conservative, the integration does not depend on the path. Okay? All right, so let's try to solve this by first checking for conservative. Let's check if it's conservative. 3x squared plus 6y, and then 6x plus 2 sine pi y, which is round x hitting this thing, 6x plus 2 sine pi y, minus round y, 3x squared plus 6y. Okay. And then if you differentiate this by x, you get 6. If you differentiate this by x, you get 0 because y is considered as constant. Minus, if you differentiate this by y, is 0, but if you differentiate 6y by y, you get 6, so it's 0. So that means it's conservative. Therefore, what I can do is I can use the formula that this integral is fxy evaluated at the endpoints that you subtract. So I'm going to make use of this formula instead of trying to calculate this directly. Okay. Now, there's still another option. If you don't like this, there's another option to do this, which is to make a straight path from here to there, which is not that bad in this case, because you see, if you set RT as 2t comma t, with t between 0 to 1, that's a straight line from here to there, right? And because this is conservative, you can just assume that it's a straight line. It doesn't depend on the path, so why not take the easiest one, which is a straight line? So you take this and you compute this over this path. That's another valid way to find the answer. And I think this will be only slightly worse than what I'm about to do over here, okay? So if you have the time, try to do that way, and see that it indeed gives you the same answer as this method. Okay? All right, so what is this method trying to do? You first have to find f, right? F is a function whose gradient is equal to fx, fy. This gradient is equal to our given function f, which is 3x squared plus 6y, 6x plus 2 sine pi y. That's our f. And then, if I just look at the first part, if you take f and differentiate by x, you get that. Therefore, if I take 3x squared plus 6y and integrate by x, I'm going to get x cubed plus 6xy, right? If I integrate 6y by x, it's 6xy. And then plus what? A function of y, right? Could be a function of y. Then the second one gives you a description of f in the following way. F could be thought as 6x plus 2 sine pi y integrated by y. Because I'm saying that f differentiated by y is that, so if I take this and integrate by y, I would recover f, right? Let's see, if I integrate 6x by y, I get 6xy. If I integrate sine pi y, what do I get? What's the integral of sine? Negative cosine. Well, what about this pi? 1 over pi comes out, right? So you have negative 2 over pi cosine pi y. Plus what? H of x, a function of x. Okay. And then you match these two different descriptions. I see that these two are common, so that must be what f is. I know that fx comma y must be 6xy. And this one says it must have this term. And comparing it with this, you realize that this unknown function y must be this one, right? So I put that here, 2 over pi cosine pi y. And then hx should equal to this one, right? X cubed should match with this one. So you put x cubed. And then if you were to find all such functions, then you would put plus c. But because we're just trying to use this function for this definite integral, we don't have to put plus c there. Okay, so that's what we need. And we're almost done because now we just have to take that function, evaluate at these endpoints, and calculate. That's all. So let's do that. Equals to 6xy minus 2 over pi cosine pi y. Okay, and then plus x cubed evaluated at 2, 1 and 0, 0. You have to do this. I need more room, so let me erase. Let's erase. If I plug in 2 into x and 1 into y, I get 6 times 2 times 1 minus 2 over pi cosine pi times 1, because y is 1, okay, plus 2 cubed. That's what I get if I plug in 2, 1. Minus 6 times 0 times 0. If I plug in 0 and 0, it will be 0. Minus 2 over pi cosine of pi times 0 plus 0 cubed. All right, 6 times 2 times 1, that's 12 plus 8. 8 plus 12 is 20. What's cosine pi? Cosine pi is? Negative 1. So negative 1 times negative 1, that's positive 2 over pi. That's what you get. 0 times anything is 0. 0 cubed is 0. The only thing is here. Cosine of 0, what's that? 1. Cosine of 0 is 1. And negative of negative is positive, so it's plus, or let's just do this, minus negative 2 over pi, because cosine of 0 is 1. And then finally, if you compute this, I see that this is plus pi, 2 over pi, that's 2 over pi. So 20 plus 4 over pi would be the answer. Okay. So that's how you solve a line integral when only the endpoints are given. If only the endpoints are given, then you basically have to assume that what you're given is line integral.